Oh man, you guys, this is the ultimate problem. We are now adding and subtracting fractions with, or this time with unlike denominators. So we're adding and subtracting fractions with unlike denominators. So guess what, you guys? We will eventually have to get a common denominator, and we're gonna use the skills from example 3 and 4 to help us get a common denominator. And guys, guess what? When we add and subtract fractions with unlike denominators, we're going to be following the same steps that we used when we had common denominators. So I'm going to be looking at the steps from when we did the ones with the common denominators. Okay, so I'm going to have this up here. I'm going to go one step at a time, though. Okay, so the first step, it says to factor only the denominators and make sure that the first term, or the term with the highest exponent, is positive. Which, looking here, all my first terms are positive, so we're good to go. So the next step, we factor only the denominators. Okay, which my only denominator that can be factored. Holy hot dog, you guys are so smart. It is this one. This one's a degree 1. Guys, if you have a degree 1, it cannot be factored. You already factored it, or it's already factored for you. So the only one I can factor is this bad boy right here. So I have 3 terms. What's the only factoring technique that we can use when we have 3 terms? You guys are so smart. It is slide and divide. So guess what? On this one, I'm going to be sliding and dividing. Slide and divide. Okay, so my A is secretly a 1. I'm going to slide my A to my C, and I get 2. So I'm trying to find 2 numbers that multiply to equal AC, which is 2, and add to equal my B, which is a 3. So, what are 2 numbers that multiply to be 2 and add to be 3? You guys are so smart. I don't know why I teach anymore. Okay, it is 2 and 1. 2 times 1 is 2, and 2 plus 1 is 3. So then after this, you guys, we form our parentheses with our x's, and then we drop these numbers directly in here. So it's a positive 2, so it's x plus 2, and it's a positive 1, so this is x plus 1. And don't forget, you guys, the most important part. We gotta slide. We're pros at sliding, but sometimes we forget about the whole dividing thing. So, after you slide, you must divide by whatever you slid over, which in this case, we slid over the 1. Okay, we slid the 1 over, we slide A, we gotta divide by A. So at the very end, you divide by the A value, which in this case is 1. Okay, so 2 divided by 1, we're going to simplify now. 2 divided by 1 is 2. So this will be x plus 2. 1 divided by 1 is 1 times x plus 1. Holy hot dog, right? Okay, so now I'm going to rewrite my fractions with the new factored form. Okay, so now what we have is 1. I'm going to branch this off. Okay, we have x minus 1 over x plus 2 times x plus 1. Plus x over x plus 1. If you want to put in a parenthesis, you can. It does not matter on that second one. Okay, so next step, we factored the denominators. Check. Next step, come up with a common denominator. Okay, so remember, we grab one of every single factor we see in the denominator, and if you see one that repeats between both of the denominators, we pick the one with the highest exponent. So I see an x plus 2 here. I don't see any more x plus 2's. So my common denominator is x plus 2. And then I see an x plus 1 here and here. So which one do we pick? Okay, it says from the previous problem, if we see the same factor repeat, we pick the one with the highest exponent. So which one has the highest exponent? Well, I don't see one, so each of these secretly have a 1. Guys, if they ever have the same exponent, it doesn't really matter which one you pick, because neither of them have the highest exponent. So I'm just going to pick x plus 1, since they both have an x plus 1, and they're both to the first power. So yes, this will be our common denominator. Get excited. Okay, so next up, after this, what we're going to do, next step, determine where the expression is undefined. So we're going to set every single factor in the common denominator not equal to 0, or else a cat will die, and we're not trying to kill cats here. Okay, so our undefined piece, undefined, We're going to set every single thing we see in the common denominator not equal to 0. So I'm going to set x plus 2 not equal to 0. And I'm also going to set x plus 1 not equal to 0. So you set every single factor in here not equal to 0. Okay, so on this one, I'm going to subtract 2 on both sides. 2 minus 2 is 0, cancels out. And 0 minus 2 is negative 2. So on my first side, x cannot equal negative 2. Okay, and on my second side, to bring 1 to the other side, we subtract 1 on both sides. And 1 minus 1 cancels out and turns to 0. So we're left with x cannot equal 0 minus 1 is negative 1. Alright, so this kind of stays in the back of our brain. We only address this if we get answers that are negative 2 and negative 1, which if we do, it's always called extraneous. Alright, so this step is done so. Bam! Step 4. Whether or not they want to, we're going to force or make all of our fractions have a common denominator. So they must all end up with this as their denominator. Okay? So let's see here. My first one, I already have x plus 2 and x plus 1. So this fraction is good to go. So I'm just going to write this as, let's see here. I'm going to choose a different color. Let me pick purple. Pretty purple. Alright, so x minus 1 over x plus 2 times x plus 1. Okay, so this fraction's good to go because it already has the common denominator. Now, this one over here, it is not quite up to our standards yet for our common denominator. We have an x plus 1. Okay, so this part is good to go. But what are we missing, you guys? What does it need to make x plus 2 times x plus 1? Well, we already have x plus 1, so all it currently needs is an x plus 2. Okay, so in order to make it have an x plus 2, what we're going to end up doing is multiply all the parts that it needs. So it needs the x plus 2, so I'm going to multiply it to have an x plus 2. But if we ever multiply something to the denominator, we got to do it to the numerator. Okay, so again, now, if you see, I have the common denominator. I have x plus 1 times x plus 2. Okay, so, and again, anything it needs to make the common denominator, you multiply it to it, but if you do it to the bottom, you have to multiply it to the top. Okay, so, we made all the fractions have a common denominator. Bam, check. Okay, now we're going to add the numerators, but keep the denominator as a common denominator. Okay, so now, when we multiply straight across, this fraction is going to have a denominator of x plus 1 times x plus 2. Okay, so let me rewrite this bad boy right here. So I have x minus 1 over x plus 2 times x plus 1 plus, okay, x plus 1 times x plus 2 is x plus 1 times x plus 2. Remember, you guys, when you multiply fractions, you go straight across. And then the top, in order to multiply x to this, we got to distribute that thing. Bam! So x times x will give me an x squared, and x times 2 will give me a 2x. So now, do you guys see? We have common denominators. Look at those things right there. Whoa, sorry, not that close, you guys. Okay, we now have common denominators. Okay, so now that we have common denominators, sorry, got your close-up that you were dying for. Now that we have common denominators, we write this over one denominator. So this thing right here is going to be x plus 2 times x plus 1, or x plus 1 times x plus 2. Doesn't matter the order. All right, now I'm going to add my like terms. So I have x minus 1 plus x squared plus 2x. So let's add our like terms. So I have x plus 2 times x plus 1. All right, my highest exponent is x squared, so I'm going to start with that right there. Bam. Okay, so this one's good to go. My next highest exponent are my x's. So I have an x and a 2x, which x plus 2x gives me a 3x. All right, and then lastly, let's see, we have a negative 1, and guess what? That's it. Nothing to combine to it, so it's minus 1. All right, so now it says, let's zoom back out a little bit. Sorry, guys. Got a little carried away with the zooming in and out. All right, so now it says, simplify and factor the numerator. And if we have any, we're going to divide out any common factors. Okay, So we have simplified. Let's see if we can factor the numerator, which the only technique we can use to factor the numerator is slide and divide. Now before we do this, let's think about this. To slide and divide, we slide the a to the c, which there's secretly a 1 in the front. So if I slide 1 to -1, that'd be -1. So we need two numbers that multiply to be AC, which is -1, and add to be B, which our B is 3. So let's think for a minute. Are there two numbers that multiply to be -1 and add to be 3? Oh my goodness, you guys, do you see it? None of them work. There's nothing that multiplies to be -1 and adds to be 3. The only thing that multiplies to be -1 is 1 and -1, which 1 and -1 totally do not add to be 3. So guess what, you guys? Factoring is going to fail us. We cannot factor the numerator and simplify this down anymore. Okay, so since I can't factor the numerator and I can't cross out any like terms in the numerator and denominator, that's it. That would be our final answer. So our final answer, you guys, which I didn't really leave much space, so I'm going to write it up here. Our answer is going to be at the top and be proud and large at the top. Our final answer is x squared plus 3x minus 1 all over x plus 2 times x plus 1. Bam! That problem is donezo. Wasn't that fabulous? I love adding and subtracting fractions. I mean, fractions are our friends, so we must love doing this process. Alright, it's been totally awesome, you guys. Thanks for adding and subtracting with me.